Alright, so we have non-face-to-face for the third hour of our tutorial for this week. So let's have a look at the question. So we have the reaction of nitrogen oxide with half of bromine produce NOBr. So we have second order in nitrogen oxide and first order in bromine. The rate of reaction is given 1.6 times 10 to the power of minus 8 mole per liter per minute. And last but not least, the nitrogen oxide concentration is 0.2 molar while the bromine concentration is 0.030 molar. So the rate of reaction given is not the rate constant. This is not K. Alright, this one is the rate, which is 1.6 times 10 to the power of minus 8 mole per liter per minute. So if you look at here, the units for the rate is similar to the zero order of reaction, but this is not a zero order reaction because here we have rate, not the rate constant. So A, the question asks you to calculate the value of K. Since we have the rate and also the concentration for each reactant with their respective order, so we are going to use the rate law equation. So we are going to use the rate law, where rate is equals to K concentration of nitrogen oxide to the power of 2 concentration of bromine to the power of 1, since here we have second order reaction and here we have first order reaction. So to calculate the value of K here, what we are going to do is we are going to substitute the information that we have in the question into the rate law. And then you will get the value of K. But the problem is, what is the units for K for this reaction? If you still remember our previous video, we had talked about how to find the units of K for each order of reaction. Okay, so same here, we are going to apply the same method to determine the order of the rate constant for this reaction, right? Since we have second order in NO, right, plus with first order in bromine, so the total order of reaction is third order. So let's say we change the concentration for the both reactants as A. So we will have rate is equals to K concentration of A to the power of 3 for the third order reaction. So substitute the unit. You will get K is equals to molar per minute as our as our rate of reaction is in mole per liter. So mole per liter here is actually molar, right? And then our concentration here, concentration of A is also in molar. So we can cancel it out. Here we have 2. So the units will become molar minus 2, minute minus 1 for the third order reaction. B, given the new rate of reaction for this reaction and also the concentration of nitrogen oxide, the question asks you to calculate the concentration of bromine. So again, we are going to apply the same rate law. Okay, and just bear in mind, even the concentration is changes, the value of K will still be the same. Okay, K does not change when the concentration is changing. Okay, but K will change if you change the temperature, right? Since the question didn't mention about the temperature, so we assume that this reaction is at the same temperature. So substitute the value, and then you will get a concentration of bromine in 0.142 molar. Next, if the rate of reaction is 2.0 times 10 to the power of minus 6 and the concentration of bromine is 1/4 concentration of nitrogen oxide, determine the concentration of nitrogen oxide. So now we have concentration of bromine, we change it into 1/4 concentration of nitrogen oxide and then substitute it in our rate law. You will get the answer concentration of nitrogen oxide 0.1817 molar. So question number 2, right? So we have the rate constant. So now we have the rate constant is given at 23 degrees Celsius. So if you look at the question didn't give you information about the order of reaction, but actually you can find it from the units of K. So since the units of K in this reaction is per molar per second, so per concentration per time, so this is a second order reaction, right? So we can use the second order reaction, okay, the integrated equation for the second order reaction to solve the problem. A, if the initial concentration of iodine is 0.086, okay, calculate the concentration after 2 minutes. All right, so we have, all right, T is equals to 2.0 minutes, and then this one is the initial concentration of iodine atom. So by applying the second order integrated equation, since we have time and concentration here, so we have to use this equation. All right. So substitute the value. All right. So remember the concentration of I here is the concentration that left at that time. Okay. Concentration that left at that time. So for A, we have to find the concentration of iodine that left after 2 minutes. And then substitute the value. All right, so remember our K here is in seconds, so we have to change the time here in seconds. So times it with 60, and then solve it, you will get the concentration of iodine at after 2 minutes. And then B, calculate the half-life. Okay, if the initial concentration, so we have two initial concentration given, right? So here we are going to apply the half-life formula for second order reaction. So if you still remember, I already teach you how to derive the half-life formula. Okay, if you can't memorize the half-life formula, actually you can derive it from the integrated rate equation. Just convert the concentration A is equals to concentration of A naught over 2, and then solve it to get the T half. Right, so for the second order reaction, the formula of T half is equals to 1 over K concentration of iodine initial. And then substitute the value, you will get 3.40 times 10 to the power of minus 10 seconds. So since our K here is in per second, so we have to use second for time. And then for B2 Roman, so I'm going to change the answer and also the initial concentration. There you go. So you get the answer, 2.38 times 10 to the power of minus 10. Right, so for the face-to-face question, all right, so we have a data for 3 experiments. So we have the concentration of each reactant and also the rate of reaction. So the question asks you to determine the order with respect to each reactant. So if you still remember, there are 4 ways to determine the order of reaction. First, you can get it from the units of K. Second, you can use the initial rate method. So this one here is the initial rate method. Third, you can determine it by plotting a linear graph. Okay, so each order of reaction got different graphs. So there are different graphs that you need to plot. And last but not least, you can have it from the concentration versus time graph, which is look at the T half of reaction. Compare the first and second T half of reaction. So for the initial rate method, so we are going to write down the general rate law. So let rate is equals to K concentration of CH3, CH, CH3 to the power of X. Okay, we put one unknown here, and also concentration NaOH to the power of Y. So actually you can use any unknown that you want. If you don't like the XY, you can use A, B, C, D. It's up to you. So now I'm going to find the value of X first. So we are going to compare the experiment that have the similar value for concentration of NaOH and different value for concentration of CH3, CH, Cl, CH3. Okay, so from here we have experiment 1 and experiment 3. Since we already know that the value of K is still the same even you change the concentration, so we can cancel it out, and also the value of concentration of NaOH for this rate is the same, so also we can cancel it out. And then you can substitute the value into the remaining. You should get 0.333 equals to 0.333 to the power of x. So to find the x, we are going to put log for both sides. So you will get x is equals to, x is equal to 1. All right, so write down this sentence, okay, to conclude that first order in concentration CH3, CHCl, CH3. And then find the value of y by comparing experiment 1 and 2, since here for this concentration we have the same value, so we can cancel it out. And then this one we need to find the y, so we need to choose the one that with different concentration. Right, so again we can cancel out the K and also these two concentrations since they have the same value, and then substitute the value in the remaining. You should get 0.5 is equals to 0.5 to the power of y, and then log the both sides. Or if you don't want to log the both side, you can actually know that 0.5 to the power of 1 is equals to 0.5 to the power of 1. So actually y is equals to 1. And then don't forget to write the sentence. First order in concentration sodium hydroxide. And then B, write the rate equation. So actually, the rate equation here is referring to the rate law. It is the same thing. Okay, do not write the differential rate equation. If the question want the differential rate equation, they must put the differential in front. Okay, so since we already have the order of reaction for both concentrations, so just transfer it into this. So we will get rate is equals to K concentration of CH3, CHCl, CH3 to the power of 1, and also concentration NaOH to the power of 1. So that's it.